Hello, everyone, and welcome to our webinar. We're going to be covering Primexx's journey with Novi. So first, before we get started and as people start to trickle in here, I want to learn a little bit more about our audience and so that Michael can also learn about that. So I have a warm-up poll for you here. So let me go ahead and start that one. You should see a poll launched on your screen. Let me know in the chat if you're having a problem with that. So the question is, what techniques are you using to model development optimization? Just kind of want to get an idea of how many people we have who have experience with machine learning or other different methodologies like standard DCA or physics-based modeling. Okay, so we've got about 14, 15, 17. Okay, still rolling in. We've got 42%. Fill it in if you've got a chance here. We got a couple more seconds here before I'll go ahead and close it. It is a multiple choice, so feel free to put in multiple answers there. Of course, I'm sure many of you are using more than one technique. Okay, looks like those are wrapping up. I'm going to go ahead and end this and share the results. So it looks like our top result was machine learning used for development optimization. So that's pretty good. Just under 70% of you have a lot of standard DCA. Physics-based modeling actually coming in last place with deterministic analysis at 42%. I do have to say 0% not using any in-house technology you're not aware of. So that's great. But thanks for your response there. I'm sure that'll be helpful for us today. So next, I'd like to go ahead and introduce Michael Mast. Michael is the subsurface engineering manager at Primexx, which has had, as any of you who've seen the news here, a successful run in the Southern Delaware Basin. We're excited to have him speak with you today because Primexx have been strong users of Novi, and they have a lot to offer in terms of the power of machine learning for asset development optimization, which is today's theme. So while Michael is presenting, feel free to put questions into the Q&A or discussion or anything into the chat. I'll be monitoring that as we go along. And whenever Michael's finished, we'll have time for a discussion and questions. All right, Michael, go ahead, turn your camera on, let's get the screen share, and we'll be good to go.
Awesome, thanks, Ted.
Yeah, you're welcome.
Let me share my screen here. Yeah. Thanks for that introduction, Ted. So yeah, as Ted said, I'll be running through this presentation, give a bit of a glimpse how Primexx used Novi's platform in our well planning and decision-making processes. I wanted to say up front that I'm not my role at Primexx. I guess I'm not the money guy or the valuation guy. My use of the Novi tool my goal was to make the most accurate forecast as possible, try and shed some light on all these parent-child uncertainties I'm sure we're all acquainted with, and then take those accurate forecasts and pass them through other workflows in the company with other departments to really pick that optimum development schedule based on whatever financial metric of interest, whichever price assumption, whichever CapEx assumption, so on and so forth. So first here, the obligatory background slide for those that perhaps are not familiar with Primexx, but we're here in the Southern Delaware Basin, southwest of Pecos along Highway 17, of course, backed by Blackstone, approximately 35,000 acres, all Reeves County, as you can see. At time of sale, we're around 18,000 BOE per day, and then the asset has approximately 300 identified locations remaining on it, 2/3 of which are 2-mile laterals. So before I get into Novi and the workflows and all that, I wanted to kind of give a background, a little rough timeline here of Primexx's operations on the asset. And I think, this on the left of the slide here is a slide I lifted from Callan's Primexx announcement. I think it kind of gives a good example of what we were doing on the asset there, or definitely at least of my first bullet. So 2017, the current management team gets in place at Primexx, and through 2019, I think our operations were can largely be summarized as, focus on, of course, getting everything HVP, proving up different horizons, proving up the extent of the different horizons. Obviously, we're getting close to kind of the edge of the basin there to the southwest. We collected a lot of great data along the way through the bid, of course, as one does, but then through an extensive pilot hole program and got some great results also. But if we're being honest, if we're going to call a spade, we recognize that we were not experienced with infill development. It was obviously a concern. So we began planning and then executing a science pad execution in 2019 with the intent of using all that great diagnostic data to eventually build out and to inform a physics-based workflow to help answer those spacing questions moving forward. So 2019, 2020, that physics-based workflow is underway. We had also been working on and subsequently developed an internal spatiotemporal model to help inform type curve risking of infills. Unfortunately, as that physics-based, that science pad project started wrapping up, at a certain point, it became apparent that it wouldn't really be producing actionable conclusions that we could use in planning our infills. Then, of course, early 2020, the weak market comes along, followed quickly by COVID-19. It put our plans on hold, as I'm sure it did many others. But then during that shutdown, we continued working on our internal model. And then later in 2020, as prices began to increase and stabilize, we had a small restart program, all single wells. All of these were ostensibly like single bounded child wells, I guess I would classify them as. And all these wells were planned via our internal model, all the spacing as a function of depletion and whatnot based off our internal model. As these wells came on, we saw a pretty good agreement between our forecasts and actuals. And that was of course encouraging, but we recognized the need to enhance our modeling capabilities if this was going to become our go-to methodology moving forward. So that's late 2020 there, started talking to the folks at Novi, and then fast forward to where we're at now in 21, where all of our multi-well development plans are made via my workflows in the Novi platform. So this is a little snapshot of the state of Primexx's analytics prior to Novi. So this is that internal model that we had been working on and using that I referenced. So effectively, it's a 4-factor model, starting with this reservoir quality baseline there on the left of the screen. I'm representing by this heat map across the AOI. You start with this baseline and then make adjustments to it via these 3 different effects: parent effect, sibling effect, completion effect, all of which are kind of empirical relationships we derive from the data set. And out of this, you get an oil IP180 and an oil IP360 estimate. Some little details about this. It's very dependent on public data sets. I mean, this doesn't utilize any of our own, proprietary subsurface data. We're not able to leverage that in this workflow. It is pretty time intensive. There's not a whole lot of automation built into it, and it's kind of iterative to get it tuned correctly to be reasonably accurate. But in some scenarios, it actually is pretty accurate. Specifically for Wolfcamp Upper A coplanar relationships, it does a really great job. But really, accounting for other zones or communication across zones leaves some to be desired with this model. And of course, it only provides forecasts for the oil stream, nothing with respect to gas or water. The errors of this model, I'm summarizing here with MAPE, the median absolute percent error in that table in the top right. For the Wolfcamp Upper A, we're seeing around 17% at IP360, and the lower A was around 24%. Again, this was largely made to inform Wolfcamp Upper A. But for other zones of interest in this area, potentially your Third Bone Spring sands, your Wolfcamp Bs, Wolfcamp Cs, this model simply isn't appropriate to use. So, we did use this in helping to plan those initial startup program wells, saw good results. We saw value in this, but again, definitely recognized a need to improve upon it. And that's my segue here into our work with Novi. So I believe it was December 2020. We signed paperwork, of course, and then March 21, we published our first model with Novi, and then now today we're running on V11 of that model, which is a bit of a misleading name. There's been many subversions along the way. I think we've published around 30 or so models. All that aside, this is a representation of our current model build. The SHAP NATO on the left here shows all of the features in our model in order of importance. And I had to edit out the actual feature names, but I'm displaying them by their feature category. And you can see here that this model makes large use of our subsurface or geology in this context data. And if you look on the top half of that SHAP NATO with the most important features, it's really dominated by a few key geologic features as well as some completion and spacing features. And then regarding air of this model, moving into the middle of the slide here with this line chart. This is my mate versus time plot summarizing the air that we're seeing in this model per stream. So again, that's a change. We now have ability to forecast gas and water in addition to oil. And then those airs, the oil airs, I should say, are summarized in that top right table. So we're now able to forecast in the Third Bone, the Wolfcamp B, the Wolfcamp C, and getting much lower airs or much higher accuracies, however you want to say that, across the board, really. Another capability of this model is being able to look at how the interplay between these different features, the dependence of them. So the scatter plot on the right is an example of that. This SHAP dependence plot, as we call it, is on the y-axis. I'm showing SHAP impact. On the x-axis is the proppant per length, and then I'm coloring these dots, these points, by another feature, distance to offset neighbor. So in this case, the wells with further neighbors are colored red. The wells with closer neighbors are colored blue. And at least to me, it certainly suggests that, farther neighbors, these red dots can and do certainly benefit from a higher loading completion. Whereas wells with closer neighbors, again, the blue dots, there's a reasonably well-defined shoulder where higher loading completions simply don't contribute to higher levels of productivity. So being able to recognize this, understand this, and quantify about where that shoulder, where that rollover point is, has really helped us in right sizing, if you will, our infill completions at Primexx. So that was a little bit of detail about the model, a little bit of overview of the airs we're seeing. This slide goes over how I might utilize this model, at least at the pad level, to hopefully get towards whatever an optimum development is. So in this example, this is my DSU of interest here in map view. I have a rough gun barrel beneath it showing I have a Wolfcamp Upper A, a Wolfcamp C in the west, parents, obviously, a Wolfcamp Upper A and a Wolfcamp Lower A parent in the east. And obviously, we need to make some decisions about the best way to infill this. We're going to have some level of degradation on those immediate infills offset the parent wells due to depletion and whatnot. We might have some degradation on the interior wells due to proximity of co-completes. All these big questions, but I'm going to let Novi solve these for me. So in this scenario, I might kind of brainstorm this 7 well, 8 well, 9 well infill pad design, feed those into Novi, run a pre-drill forecast for each of them, and then observe the results. So these cum oil versus time plots on the right. And I'm evaluating those results relative to these dashed lines, this economic target. Those economic targets, it's a synthetic curve we generate outside of Novi. Ostensibly, it's the representative well that meets our internal hurdles. So whatever our assumptions are at that point in time, you know, whatever our economic target is at whatever price assumptions, CapEx, and so on and so forth, that's our internal hurdle, right? So evaluate these ones, select the pad that best meets or exceeds that internal hurdle, and then continue forward. Of course, in the event that one of these pads we decide doesn't, I just iterate again with higher density, lower density, what have you. But once we make that selection determination of what we're deciding is optimum, I can move forward in the planning process, you know, write out a Novi, export out coordinates of those sticks to my geology department for well planning, export out these curves to reservoir finance for more thorough cash flow modeling or whatever we want to look at, and then repeat this process. I can repeat it for different price assumptions, or I could repeat it for other DSUs. So for the remaining DSUs on my asset, I could do this workflow, come up with that optimum design, and then take all those winning pad designs and essentially build out a development schedule, obviously working on appropriate timing across all those. And now at the asset level, it's really similar, just zoomed out a little bit. So, you know, whether I'm looking at my own asset and trying to develop, you know, inventory as a function of price or what have you, or more for an M&A purposes, look at another asset, this is generally how I would do it. Take that entire asset, and then for whatever prices I'm interested in looking at, in this example, 50, 60, 70, I would just infill the entire asset with some kind of baseline density. So for this $50 assumption, I might start with this 14 well per section pad density, infill the entire asset with that, and of course, eliminating wells to account for existing PDP, and then iteratively run pre-drill forecasts until all the wells are meeting my internal hurdle. Meaning I might have to delete some wells, respace them, run it again, or perhaps I was too bearish in my initial assumptions. I might have to add some wells, decrease spacing, so on and so forth, until for each price assumption, I'm able to export stick count per well forecast, and then when applicable, run that through and do type curve risking per well again. So if this was an internal exercise, I can readily provide those exports to my VP asset development. If this is for an M&A type conversation, I can provide these exports to my VP business development, and they can start working on, you know, appropriate bid pricing and whatnot. So kind of based on where we're at with the tool, our comfortability, our familiarity, and I guess kind of our confidence in the model results, this type of workflow takes me approximately 2 days for each of these different scenarios. Of course, that's a bit of a function of the size of the asset, but for something like this, 30 to 50,000 acres, 2 days is a pretty reasonable estimate of time invested. So I guess kind of the big question is, how well is it working? What kind of results are we seeing? This slide here shows our Primexx's most mature pad completion planned with this Novi workflow. So on the line chart here, I'm showing the Novi forecasts in the solid lines, and then the actuals with the dotted lines there. So these wells are a couple weeks short of 180 days on, but we can see the orange and the green wells are sticking extremely close to forecast. The blue well does appear to be falling short of forecast. But if you run the numbers on these right now, we're seeing about a 7% absolute error between forecast and actual. And at least in my opinion, this is a much tighter accuracy than we could have gotten, certainly with a physics-based approach and also a deterministic risking type approach. This is my last slide here, to wrap up, the presentation. And, I guess in so many words, Primexx's journey with Novi is over, right? So obviously, as Ted alluded to, the asset has sold to Callan. So that journey has reached an end state. So I'll leave it here with a quote from my boss, Sam Blatt, the COO, regarding our work with Novi and the value that we saw in it at Primexx. But with that, Ted, I can put it back to you if we want to open up the Q&A.
Great. Thank you, Michael. That was really interesting presentation. Good to hear kind of really the whole workflow and history of you guys working with Novi. So along those lines, and by the way, go ahead and submit questions in the chat or in the Q&A, y'all, and we'll be happy to answer them either for Michael or for the Novi side. But along those lines, if you were, winding back the clock here to when you guys were signing the paperwork or even earlier in your analytics journey, what kind of advice would you give to your past self to be as successful as possible as early as possible?
There's probably a fancier answer than this. This is cliche, but data cleanliness, data quality. Obviously we had been working on some analytics on our own. So if you would ask me then, I would have been of the opinion that we did have a very clean, curated data set, well headers, production data and such. But it wasn't the case. I mentioned we published like 30 models, right? Some of those models, did represent really like phase shifts in our understanding and, optimizing our interpretation of subsurface. But a lot of those iterations were simply, identifying, some of our data sets were lacking in cleanliness and just in fixing those problems.
Yeah. Cool. Yeah, that's always very important. Another thing that we hear about all the time that kind of struck me as we went through this presentation. We have a lot of Primexx people here on the line, but a common question that we get is how can you build organizational alignment behind machine learning and getting that buy-in at kind of multiple levels within the organization to have an open mind or use these tools in routine development optimization or asset valuation type workflows. So do you have any hints or comments on what your compadres here on the call can do to help improve that organizational alignment?
Yeah, maybe. So I think whatever hesitancy folks on the Primexx team had initially, I think we're kind of in two buckets. Either, one, does it actually work? And two, what kind of extra work is going to be required to populate it with meaningful inputs, right? So I think, solving that, it's just like education, and then being able to, what I want to say, being able to demonstrate the results to kind of, quell the issue. Because a lot of times, I'm guilty of this myself too, but, in the machine learning space, it is new territory for many of us. And, in some instances, it can just sound like a marketing term or a buzzword that people might use. And people get kind of these, aversions to things that appear to be black boxes, at least to them. So, education of what it really is, how it works, and then being able to display the results of it was definitely key. And then, especially working with my subsurface guys and getting them to recognize just, how simple it was to take our existing data and get it into this framework and immediately start leveraging it without having to invest more time or capital was impactful.
Yeah, thank you. Let's see. Got another question here coming in from Chris Doyle. What's next? What would you like to see in additional functionality from Novi?
Okay. No, and I think, I guess what I'll call an optimizer loop. Be careful, because that's effectively my function. I mean, I am the optimizer loop, but the way we're using this tool, and maybe there's better ways to use it, is we're trying to goal seek a certain target, right? And that does take time. I mean, I think the results are certainly valuable. It's a good investment of time, but really, yeah, if there was some way to plug in, hey, we want this result, how do you meet that with the most sticks, or what configuration, optimizing spacing, all that. And that's what I'm kind of doing manually, but yeah.
Okay, that's good. That's good product feedback. Yeah, I'll see if we can work that into the roadmap. No, we definitely have some plans for after we kind of finish our model engine tool to turn our product development efforts to well, for anyone here who's familiar with it, to improving the optimization workflows within Forecast Engine, which right now works plenty fine, but it can be maybe a little more manual than you'd like in the dream. We've got another question coming in from the chat. This is from Matt McGuire. Hi, Matt, over at Diamondback. I know this works on data analytics and is probably best when predicting lots of wells. Did you feel it did a good job even with small groups like 5 wells, or do you feel like you need bigger groups to get a better answer? And also, Michael, you can go ahead and exit your slideshow, I guess, so that it's not mostly just a big black screen.
Oh, sure, yeah.
Yeah.
I'm not totally sure I understand the question or the intent of the question. So like, the model that I spend most of my time in is, I guess, what I call my AOI model. That one, after data completeness checks, is something like 2,300 wells there in South Delaware. But I mean, as far as, but how do I say this? It's like at the individual well level, is extremely accurate. At the pad level, it's extremely accurate. I guess like we don't have we haven't done any work like on the order of like single digit numbers of wells.
Yeah. Okay. Well, thank you there. We had another question come in from the chat, and if you guys have anything more, it's we're running near the bottom of the hour, so go ahead and get them in. And I think we maybe have time for one more after this. But Anton Valuev, hope I pronounced that right, asks, did you use any synthetic data to train the model?
No, I mean, unless you guys did, to my knowledge, no.
No, we just used we worked with what you guys had. Yeah. Yeah, I guess synthetic can be a broader question, but no, I don't think we generated any synthetic data types. Okay. Last question here, actually coming in from Alex from Novi, but did the lessons learned from the past physics-based or the internal analytics models help influence the machine learning workflow?
I think, yeah, I mean, certainly in some ways it did. It kind of primed our minds to work in a certain way. It was definitely a leap jumping from, this kind of, MVA type process into a Novi workflow, but we were at least in a good point to manage that transition. We weren't coming in completely fresh.
Yeah, that's good. Okay, everyone. Well, we've made it to the bottom of the hour here. Want to say thanks again so much to Michael for providing this presentation, and to the entire Primexx team for being such good partners with us and helping to share their lessons with the broader community here. If you have any more questions or thoughts, I've put our info down in the chat, email addresses, etc. You can also reach out on our website. We'd love to hear from you, your comments, or any other questions or feedback that you have. But let's just say thanks again to Michael, and thanks everyone for attending, and we'll talk to you all again sometime soon. Bye.